Alright guys, welcome to another quick video. Today I just want to go through some of the major changes and some of the useful documents that you're actually going to need for the structures team. It'll be pretty much where you're going to want to go to get all of the necessary information that you need to do to kind of do the research and do the design work that you need to that we're going to have to do over this winter break and over the course of next semester. So to kind of get started, I'm just in my Google Docs over here. Make your way over to shared with me in general team and just open up that general team folder. If you do not have access to this folder, make sure to let me know. This is pretty much where everything is stored, and if you don't have access to this Google Drive, you pretty much will not have access to any of the documents that we create. So to start off, hit on general team. Two things that are important. Reports right here. This is where we're going to find all of our reports that we're going to be sending in as a team together. This is where the TRR is. So this is the document we've been working on for the past few months. And this details about the test stand. So if you're interested in that, give that a read. It's like 250 pages, so have fun. It was a lot of fun writing that, as you can probably guess. But our main folder is going to be found over here in the general divisions folders over here. So just click on in that and make your way over to structures and open that. So this is where hopefully your screen will look like this for your structures folder. The way that Google Drive and Google Docs work sometimes is that even if I clean up the drive and I delete and I move stuff around, it will not permanently delete stuff for you guys. So please make sure that your drive looks like this. These folders should, all the documents should be moved from the extra folders if you see any, but delete those and delete anything inside the main area that does not have a number in front of it, and except for this engineering design tree photo here. And the thing is, you won't be able to delete them. Well, you will be, but it won't delete for everyone else. So if you want to delete it or remove it for everyone else, just move the stuff into this old folder that I just created. So if you see anything here that you don't think should be there, and if you want clarification at a meeting, just show me your drive and I'll tell you kind of what's relevant and what's not. But everything that's relevant should have been moved into the individual folders. So hopefully everything should be in place. But if you see something that's out of place or doesn't look right, just throw it into this old folder and that'll be that. Alright, so first thing, I'm going to try to keep the number of files in this main drop area to a minimum, and I'm going to do that by pretty much just having this Readme, which is essentially just a little guide onto where everything is, what's in the folders, and what's in what kind of folders inside of other folders. So for instance, in this general team files, there's some relevant information that helps you navigate this general team files folder. But probably the main thing that you're going to be using on a day-to-day basis when you're doing work for the base 11 project, especially for structures, is you're going to want to click on this Structures Priorities 2.0 document. This is where I've compiled, well, this is kind of explaining what it's about, but it's essentially just an area where we can compile all of our relevant information for overalls of vehicle that our subteams would need to use. So say max velocity, max height, max acceleration, max drag force, max Q, tank pressures, mass flow rate, tank volumes, HE sizing, estimated COG. I even threw in a database here, so you can go in there and look up material properties for different aluminums, steels, and different alloys of both of those. And then here's an air density plot table based on height, temperature, and pressure. So it'll give you all of those for a given height or for a given temperature. It'll give you. It's a dynamic table. It's from Engineering Toolbox. It's really cool. Check it out. And then down in here we got our CAD files. So this link right here actually takes you directly to the most current model of the vehicle and all the parts for it. So if you download all of these parts, you'll be able to look at the model in SOLIDWORKS and be able to manipulate it. So that's cool. And I'll keep this up to date so that it'll always give you the most up-to-date thing. Here's the most up-to-date drawing of the vehicle, breaks down major sections. It honestly is giving you a lot of useful information of where the tank placements are right now for very preliminary, and it puts it down here, and it gives you some information about the nose cone type, some preliminary fin sizing, and then some center of mass calculations, assumptions, and stuff like that. Down here, this is the avionics vehicle profile finding. So based on this profile, we gave this to avionics, and they ran a simulation and got height versus time, velocity versus time, drag, and acceleration plots. And they have the complete report right here. So if you follow that link, it'll boom, bring you right to the avionics information. But it's a lot of the useful information you can find from the graph itself. But if you're curious a little more, click on that and go in there. And as you can see on the side, I have some comments talking about what things might change, or if we need more information, or etc., things like that. But that kind of concludes the general information stuff. So this is a lot of information that you'll find that's useful for just general design work and things like that. But down here, I broke it down into sub-team priorities. So essentially what is done, or what we've kind of almost completed, and what's kind of still needs to be done, along with some comments on things that we're considering or should look into. And Jed went through here too and added some of his comments, so that was freaking awesome. So we got more information. But pretty much, if you're on a sub-team, look at what is done, make sure that you understand what is done and kind of why we're doing this, or why we've chosen it. And if you can't wrap your head around this, just ask me or ask your sub-team lead. They should be able to fill you in on it. And I added some diagrams for preliminary sizing, and I added this diagram for nose cone profile down here. So this is for stuff that needs to be done. So need to figure out nose cone tip material, nose cone skirt material. Oh, these need to be bold. Sorry, I'm pretty... Okay. I like to make these readable. All right, cool. Cool. So that's that. Just so if you need something to do, or you're looking for something else to do, or you want to look into more, check out these need to be done. Do some research and put them in your file in your subteam folder. And I'll show you what those will be. Actually, those, I'll just talk about it right now. So in each of your subteam files, you're going to have, so say for instance, if you're on the nose cone recovery team, since we were right there, I know they have their own document, but I really would like to see subteams import whatever they find from this document, especially for this needs to be done, and even to be done needs to be kind of imported into this. I tried to outline how I want information presented, because we're going to have to present it pretty much like this anyway for the CDR, so might as well just start writing it in the form of CDR now, so to save our time later. But essentially it's just overall proposed design of nose cone and recovery section, whatever. And then this goes over some of the major criteria for the design, like heating, sizing, material type, that kind of stuff. Secondary considerations, criteria is like we want to have the avionics equipment inside the nose cone. That's kind of a secondary. And knowns as assumptions is if we don't necessarily know what a value is, what we're assuming it to be, and why. And then this goes down into the design proposal, and then the subcomponents. If so, say for the nose cone, overall nose cone design, we're gonna have to go over the nose cone tip, and that's gonna be like what material is it, what's your proposed, what are the requirements of it, what are your proposed design of it, what's the FEA proving it works, and what's the conclusion. And I'm gonna reformat these documents a little bit, and I'll be continuously tweaking these to hopefully try and make it better. And I will actually go ahead and do a and make a example for you guys, and I will walk through that more in depth, because this is really important that we get this part done, and it's going to save our asses down the line, and it'll make it a lot easier to communicate. So I really want to start transitioning over to some type of document like this for where we record all of our design decisions. So that's pretty much, this is where all the heavy lifting is going to be doing. So just go through, check out what needs to be done, and there's a little thing down here where hopefully if we're waiting on some information for a certain team, I put the part, I put the information that we still need and kind of where we can find it. And the thing is, where you find information, you can always research. Always research. You'll probably find a lot more than you think. But we do know that Miles has a MATLAB code for ablation rates of a certain type of material, so we got to see if we can adapt that to our nose cone epoxy material once we find it. So we'll try that out and we'll see what happens. But as you continually scroll down, there's going to be your different sub-teams, so just find yours. And I want to talk about tanks and piping real quick. So tanks and piping, I still want to see that document detailing piping links and all that. But the thing is, the piping is pretty much 99% on fluids. All we have to do is find ways to mount it to the vehicle and have a raceway to cover it. That's pretty much as far as piping as far it goes with us. So don't even really worry about piping. Just follow the tutorial videos, make that piping outline for the tanks, and we'll send that over to fluids, and it'll all be good, and we'll help them start getting this done so then they can give it back to us. Yeah, and then it just goes general airframe, engine thrust structure. So just check out what needs to be done for each team, and feel free to even assign something to yourself. So like you can even just especially over winter break, if you want, just highlight something, put a comment on it saying, hey, I'm checking this out, and then just say that you're going to throw it into that appropriate document after. Alright, so that's kind of what the few things that I would like to see in this main area. I just have this engineering design tree thing. It's just quickly just reminding you this is an iterative process. We're not going to be doing this once. We're going to be doing these designs hundreds of times, and it's going to be getting better every time, and you're going to be getting better at it every time too. So just try it. It sucks. I've had to design about my base 11 folder is about like 5 gigs now because I've done so many things over and over and over and over again. But yeah, let's get back to these folders. So these are your subteam folders. So I'll kind of go into the subteam folders first. So subteam folders are pretty bare bones right now. This is where I want. So if people have their own documents off in their own Google Drive, so please put it into your subteam folder. But essentially in each of these, what I have is that status report document, that kind of one that I want everyone to start transitioning to that I showed you before. There's one of those in each of the subteam folders, and there's a CAD files with any CAD files that you guys make or that you guys need from me, and there's going to be a research folder with relevant research to your part or to your subteam. And some are more filled than others. Some have more research, some don't. It just really depends on what has been done. I kind of took all the research we did in the past semesters and threw them into here. But as you can see, I put an example tank calculation, and then this is Shavesh's document where he details what people are kind of doing and what needs to be done. So cool, keep that up, and we'll slowly start to build this, and feel free to add folders as you need it to help organize your subteams. But the kind of the star of the show, other than your subteam folders, is going to be here, the general team folders. This is where I have a few things that are pretty useful. So first of all, meeting PowerPoints. These are the things that pretty much the PowerPoints that I use in every one of my meetings. So if you want to check them out, just do so. Or if you need to find a link, because sometimes I have links for action items inside of the these general meeting documents. And I'm going to be throwing these into November. Oh. Everyone shared. Yep, we're good. Yeah, so this is where the meeting PowerPoints are. There's October there, November. I'm going to be adding December for this Thursday. So that'll be in there. Meeting takeaways, these are where, these are kind of like the action items after meetings, so like the minutes essentially. They're the meeting minutes. Equations and references, I'm going to slowly start to build this up. But this is where you're going to find documents for equations. So compressibility factor, tank calculation. I'm going to be trying to add to this like crazy. So this should be where you go if you need to find how to calculate something. And in here, this describes the load cases for the vehicle. So at different stages, what are the active loads on the vehicle? I'm not sure what this is, honestly. This is JED's thermal expansion calculation based on stainless steel 304. So it predicts based on changing temperature how much a metal will contract or expand. And then this is the materials. I compiled all of our materials research into one document. It's kind of a mess, but it has links and it has useful information. So feel free to check it out here. And I even did some research on NASA space tiles and aerogel. So if you're interested in those, they're pretty cool, but they're kind of overkill. All right, so that's kind of equations references. I'm going to be continuously adding to that, but it's going to take a while. And if you find any cool equations, throw them in here. And I just want to start to make a database of materials and equations that's useful to us. And then 4 here, this is the CAD files. So this is the old rocket model from May. This is the new one from November. And this is the drawing format. So this is the drawing format I use for my drawing. So it has like the FTR logo and that kind of stuff on it, and it has like the error tolerances and that kind of stuff. So I'd recommend you use this. Otherwise, you can, I guess, make your own. But yeah, it has these are your model parts. So if you download these, you'll be able to first see the drawings that made these, and you'll be able to edit these and also edit this vehicle model yourself. So if you're working on the tanks team, you'll be able to try stuff and try to see how to mount it to the rest of the vehicle, that kind of stuff. Other than that, reports. So this is where we're going to be keeping all of our reports that we make. So we have our CDR flight vehicle. This is empty, so this is where we're going to be putting stuff later. PDR, this was our original stuff. So this was information from last May. This was not very well made at all. The thing is it was very difficult at the beginning understanding how to write these reports because no one had ever done it before. So we've kind of learned a lot since then. So that's kind of why I'm moving more towards those status documents for the design, where it's individually, each section will be made exactly how it's going to be thrown in the CDR, and we just plug and play, and it'll be really easy. Okay, so that is reports, lead specific. This is going to be information that's going to be important for the leads. So like this is team management stuff. Probably not really useful to you guys, so I don't really see a need for you guys to check that out. Old, this is just essentially, since you can't delete stuff, you just throw old stuff in here. So that's I made that for this. So if your general team file does not look like this, essentially throw everything else in old. But this is that status document template. So this is a reference guide for where I have my original comments on everything. And I will actually make one of these for a specific part and show you how I want to do it. And I'll probably reformat this a little bit because redoing the TRR helped me think about how to present this a little bit better in a way that will be better down the road. So I'm going to probably redo that. And then here, all we got, so this is the avionics profile findings. So that's the thing that was linked in the structures priorities 2.0. So that's just where the file is. This is a copy of a picture of the overall vehicle with the overall everything essentially. And this is the propulsion specifications. So this is not the official copy. This is the one that I copied off of theirs, and then I made our own copy so then we could see everything. But essentially, what's important is this fuel tank volume and auxiliary tank volume here. So these gives you in liters. In meters cubed, it's pretty much just 0.244 and 0.173. And that has the ullage and residual space included. And we can go over here and add the inner diameter, and it'll calculate the tank lengths and the totals and everything based on a few equations we made. So that's kind of a good way to see your sizing of your tanks. And down here shows you your pressure, your tank pressure, and the injector pressure. So a lot of this, so some of this probably has changed, especially probably your pressure loss in pipes and injector pressure and tank pressures, but they're not going anything above 20 bar. So we're pretty much assuming 20 bar anyway. So we're going to be a little overkill anyway. I mean, we're just going to be a little overkill, which is fine. And that'll be that. But this is kind of useful information for mainly Tanks team. And that is kind of the breakdown of all of the documents. So if you have any questions, please, about like all of this, please bring it to the general meeting on Thursday. It's going to be our last one for the semester, so I really want to make sure that everyone has everything they need to be able to think about this over break a little bit and work on it a little bit here and there. I'm not expecting a whole lot, just that people start to get used to this setup and at least start to think about it, so then next semester we can hit the ground running pretty much and get going. So I'm going to get working on that example document for kind of how I want the designs broken down and presented. So I'll show you guys that later, but that'll be another day. So for now, just continue checking out the other teams, the other CAD videos, and I'll see you guys Thursday. Peace.